Hey guys, and welcome back. So I know it's been a minute since we've had a video, but we are moving into unit 7, which is exponential. We only have 9 units, so we're almost there. After this unit, the next 2 units will be kind of hefty in information, and it will be a lot. So just be patient, don't get overwhelmed, don't get frustrated. We're gonna do this together. So right now we are going through exponential functions. This video is just an intro. In Algebra 1, we really don't do much with exponential functions. We just kind of learn the basics and when we use them. And that's pretty much it. So here we go. An exponential function is a function that increases at an accelerated rate. There is no constant rate of change or slope. So linear, straight line was always a constant rate of change, a rise over run, your slope. We don't have that in exponential. It's not going to make a straight line. So when we did have a straight line, it looked like this. We also had a rise and a run, rise, run, rise, run. It looked like a staircase. But now we're going to get rid of that. And we can see that if I did put some stairs on here, you see how they're not the same. So that's not a constant. We're either gonna have a really smooth rise or we're gonna have a drop. And we'll talk about the drop later. Right now we're just kind of focused on, is it exponential? Is it not exponential? So 2 equations that you should be familiar with by now, or linear at least. So we have our linear, m is slope, b is our y-intercept. I want you to notice in exponential, we also have a b and we have an a. And the x is an exponent, exponent. So a and b are just 2 different numbers. That's why we have an a and a b in this equation. So a is always going to be my initial value. That's my y-intercept. It's where I start. You need to write that down. B is your rate, not a constant rate, not a slope. This is your rate. So how am I changing at every moment? And X is typically your time. If in 7th grade math or in 8th grade math, if you took that, you will remember compound interest. That was an exponential function and exponential growth. So time is typically your exponent. Okay, so we have 2 different tables. This is what you're going to be doing on your assignment today. I want to tell if these tables are linear or exponential. So I'm not going to give you, I may give you some tables that are neither, and I will show you how to find out if it's specifically exponential in a minute. But this one, we're going to see that we're adding 2 each time. It is constant. We're adding 1 each time. On this one, I see that I'm adding 1 each time on this side. However, on this side, I'm adding 2, 4, 8. So that is not constant. But if I look at my change, I can see that there is a change in that sequence. So to get from 2 to 4, I would multiply 2. To get from 4 to 8, I would also multiply 2, and so on and so forth. So I am multiplying by the same number each time. So let's just look at an exponential function. That last one, we couldn't really come up with the rule because it wasn't in just a basic form. It was shifted. I did that on purpose. So on this one, we're looking at what we're multiplying by. So on this side, of course, I put times 1 for some reason. I don't know why I put that. That is an error on my part. I meant to we're just looking at the y's because the x's were always going to increase by 1. The y's, we are increasing by 2. So we're doubling it every single time. So this would be y equals 2 to the power of x. Because if I see I have 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So we're doubling it the whole time. So that's how you can tell if it's exponential, if I multiply by the same thing. So next, word problems. How can I tell if a word problem is linear or exponential? So linear is if I'm adding or subtracting a constant amount, that is linear. If I am multiplying by a certain rate, a percentage, that is exponential. So on this first one, I can see Jennifer deposited $550 in her bank account. She added $150 each month. So what does that look like? We have our initial, which is $550. We have our slope, or our constant rate of change, which is $150. We added or subtracted monthly. This would be linear. So y equals 150x plus 550. Okay? And next one, it says Bradley deposited $550 in his bank account. He increases the balance by 65% each month. So I have $550 is my initial value, or my A, and my rate is 65%, or B. So it increases or decreases by a certain percentage. So let's plug this in. That is y equals 550 times 0.65 to the power of x. And that's really all we're doing today, just determining linear, exponential, or neither. So if you can't add by the same number, linear, or if you can't multiply by the same number, exponential, then it is neither. And that's pretty much it. Good luck with the assignment today. Today you're just doing a Google form. On tomorrow's assignment, or towards the end of class, you will see an assignment where you're actually going to have to do the PowerPoints, figure out the graph and all of that. So if you have trouble with that, just shoot me an email. I will be on to let you know how to do things. And that's pretty much it. So good luck, guys. Bye.